Hello, this is my lab report for Lab 1 over constant velocity. So, this lab uses an everyday example to help explain Newton's second law of motion. This experiment tests the principle by comparing predicted results to actual experimental data. The purpose of this lab is to explore Newton's second law by using a real-world experiment. And in this experiment, the system is the tennis ball that rolls on the counter, and the surroundings are the counter and everything else. Some formulas I included that might be useful include the F-net formula, which is also the formula for Newton's second law, which states that the change in momentum over the change in time is equal to F-net. But this also means that mass times the change in velocity over the change in time equals F-net. And since the change in velocity over the change in time is acceleration, we can simplify the formula to just being mass times acceleration. I also included the position update formula and the velocity update formula because they are useful in creating the computational model and editing the code for GlowScript. And some additional background. Newton's second law states the acceleration of an object depends on the net forces acting on it as well as the object's mass. Because of Newton's first law, we know that an object will either stay still or stay moving at a constant speed unless acted on by an unbalanced force. The ball's motion stays constant during the videoed section because there's not an unbalanced force acting on it, although realistically friction causes it to slow down eventually. Because the velocity of the ball is constant, there's no acceleration. Because there's no acceleration, F-net is 0. This means that the position versus time graph for the experiment should be an increasing linear line, and the velocity versus time graph should be a horizontal line. Here's the video. And here are the data points that Tracker collected from the video. As you can see, the time starts at 0 seconds, and each time step is 0.039 seconds. And the initial position collected was 1.761 times 10 to the negative 3. This is the graph that Tracker made. Although it's not completely linear, it is very close considering that it is an experiment. And this is the GlowScript code that I edited in order to make the computational model. The highlighted parts are parts of the code that was edited from the original starter code. To start, the initial conditions were changed. The ball position vector I changed to have the initial position that Tracker recorded. And the ball velocity I recorded by calculating, which I'll show in the next step. In addition, the time started at 0, and as I said before, the delta t is 0.039 seconds. The total time taken was 1.084 seconds, which is why the calculation loop is for time less than that. The F-net is 0 because acceleration is 0. And the ball velocity and ball position were updated using the update formulas I showed in the background information section. This is how I calculated velocity. Velocity is change in position over change in time. So I used the Tracker data to find the final position and subtracted the initial position and divided it by the total time of the video. That's how I found the velocity vector, which I put into GlowScript. These are the graphs that GlowScript created. This is a straight linear line for position versus time and a horizontal line for velocity versus time. These are how the two graphs compare. The orange line is the computational model and the blue line is the experimental model. These are not exactly alike. The experiment is not exact, and that's why they aren't exactly similar. Possible sources of error for this experiment were the video of the ball. It's possible to have kept recording even after the effects of friction were slowing the ball down significantly. And because you have to select each position for Tracker to record, it's also easy for an error to result from that. And calculation errors are always a possibility. And the experiment itself does not count for real-world factors. The counter, the ball, and many other factors could have affected the experiment and made it unlike the predicted computational model. So, to discuss, the experimental axes were chosen to represent right being the positive direction and left being the negative direction. This resulted in a positive slope. If the axes were swapped or interchanged, the slope of the graph would have a downward slope. The result of the experiment would be the same. The predicted model is similar to the experimental data and is not exactly the same because of nature and human error. The calculation of F net being 0 is not completely justified because of the existence of friction and air resistance. It would be impossible to say exactly how many forces were acting on the ball because of the almost endless possibility of outside sources that could have a slight impact on the ball.